Hello everybody in the Operating Systems Design course. This is a lecture for you. This is assignment number 7. So welcome back to another video. So assignment number 7 is the last assignment for this course, and I guess I should have downloaded the syllabus, let you know when it's due. But let's just take a quick peek here. So the assignment number 7 is due on 5/7, so it's coming up. It's coming up real soon. This is the week of the 21st. Today's the 21st. This lecture is for Thursday the 23rd. Next week you have assignment number 6 due, and then you have assignment number 7. I've already gone over assignment number 6, so take a look at the video for number 6 when you get a chance. Assignment number 7 is the last assignment, and it will be due on the last day of class, which is Thursday, 5/7. We do have a final exam right after that, but you want to complete all of the assignments before you do the final exam. I'll have more details on that in the weeks to come. So let's go take a look at assignment number 7. Assignment number 7. Now, if you've taken a systems programming course before, this is going to look very familiar. It's pretty much measuring the distance between systems programs and application level or API level programs. So what you're going to do is you're going to measure the performance of the I/O system calls. And so there's several goals to this assignment. First, to give you experience with efficient issues in writing programs. And it basically is going to show you the differences basically in the efficiency, the speed, essentially is how we're going to do it. We're going to measure the efficiency by the speed of operation and by measuring how long it takes to complete a job. We're using system calls versus higher level APIs. And you're going to get experience with process of measuring and benchmarking. And so you're going to also expand your understanding of how Linux I/O library routines are structured. And you're going to learn how to time system calls. So how timing system calls works. Okay, so for systems programs, merely printing out the correct answer is not really sufficient. The program must also run well at the same time. And when writing operating systems programs and utilities, efficiency and the speed of operation is pretty much the concern because you're at the systems level and you want programs to run as fast as possible. So you want to utilize your resources correctly, and so you have efficiency with any type of system call or any type of systems program that you're running. So in this assignment, we're going to study the cost of making I/O system calls and the efforts of buffering on reducing some of this cost. So we're going to use buffering to reduce the overhead. You'll learn about simple timing routines and use them to measure the time it takes to write a large file under various different situations. So the key specifications for this assignment are following. So here's what we're going to do. You're going to measure the time it takes to write a large file using 2 different output routines. Now you create the large file. So you go ahead and find a large file. It could be a text file, it could be a binary file. Find a file or create a file. And it's going to be a large file. And so you're going to measure it under 2 different output routines. The first one is directly calling the Unix write system call. And the second one is you're going to use a standard I/O library routine called like fwrite. So in the C language, you have, and this is an API call. So in the C language, you have an API that is called fwrite that calls the write call. The write system call doesn't do any buffering. By default, you'd actually have to buffer it yourself. Fwrite includes a bit of buffering. So you have 2 libraries. So you're going to compare the system call interface and the system call library to that of the standard I/O library, the fwrite library. So for each of the 2 cases here, you're going to compare and contrast the 2. So for each of the 2 cases above, you'll repeat the experiment using a write size of 216, 128 to 1024, yada yada. So you're going to automate this. You're going to write a program that does the write, that uses a loop that comes through and writes them in these different write sizes. And these are the number of bytes that you're writing. So in other words, for the first experiment, your program will open a file will first open or create the file, and then write to the file 2 bytes at a time using the write system call, and then close the file. It will do this 10 times, creating 10 new files, each file with a different name. So how you name it, how you design it is completely up to you. So, and then you're going to repeat it for all of the different write sizes. So that's why I say write a program, a C program that does a loop, that does it for you automatically. Your program will then repeat this process, writing 16 bytes at a time and so forth, all the way up to 64 bytes. So your program will then repeat these 6 cases using the fwrite. So we're comparing write with fwrite. All of the same code, the same routine, the same loop, but we're going to switch the writes. So the file size that we'll create each time will be 128 kilobytes. So make sure to create a file in the temp directory so that you're measuring on the local file system cost and not the overhead associated with the file server. Okay, so if you write on a directory in the hard drive, then you're also measuring I/O speed, which you don't want to do. If you write in a temporary RAM file directory, so look up temp on the Unix on your Unix system, and you'll notice that it's a RAM-based file system directory. And so if you write to a RAM disk, it's you're comparing the memory, and the memory is consistent between the two. If you're writing using a system call versus an API call and you're writing to the hard disk, what's going to end up happening is you're including the speeds for the hard drive in there. If you can't get the temp directory to work and you're writing to the hard drive, just know that you're measuring more than just the writes. You're actually measuring the disk access speed at the same time as well. So we have some timing issues. So you're going to measure the elapsed time for each of the 10 test cases. Before the start of your write loop, your program will call the get time of day system call. Immediately after the loop, it's going to also call the get time of day and compare. So the difference between the two variables is the elapsed time. So you'll also record the number of write operations, the number of calls to the write and to the fwrite. Note that the time kernel call is precise only to a second. So, we're not going to be that precise. This precision is not sufficient for this assignment. So you should use a more precise measurement. The get time of day is more precise. So there's even more precise measurement methods, such as the RDTSC, but you don't have to worry about that. The get time of day will give you a more precise than the Linux time. So go ahead and use get time of day instead. So the experiment method, well, okay, so this is a little garbage. Pretend now that you're in a biology class or chemistry class and you've got an experiment notebook and you're going to do a full-on computer science experiment. So computer scientists are notably sloppy when it comes to this. In fact, I don't think they even make experiment books. I'm sure you all, in the course of your studies through your bachelor's and master's, you probably have at one point taken a lab course where you had an experiment book. It was probably chemistry or biology. And you'll notice that we don't have these for computer science. So we don't even make it. You can't even go to a bookstore and buy a lab manual or lab book anymore. So computer science don't take good notes, and they don't record experiment results. So while you're doing a lot of experimental work, we typically do not follow up with good experimental practices. The experimental method is a well-established regimen used in all areas of science. So the use of experimental methods keeps us honest and makes us work, gives form to the work that we're doing, records the results. So specifically, you are to perform the experiments. You can have your program write out all of your notes. You don't have to hand in a lab report or a lab sheet. Have your program print out the results. So perform the experiment, run the program for each one of the cases described above, recording the results in a table or other format. You can have it done by your source code. Besides the time and the number of calls, you should also calculate the time per minute and the time per byte. So we figure out the exact speed. Summarize the results. Now this part you're going to write yourself. Write a paragraph to summarize what patterns you see in the results. Now you could put this in a Microsoft Word file, you could put this in comments in your code at the end or at the start, or you could put this in the body of the email message that you're going to send me with your source code. I don't care where you put the summary of the results, but I want to see a summary of your results. After you're running this test to see which one is faster, the F right or the right, and you're comparing the results, make a little bit of analysis, analyze it a bit, make a little bit of a note in terms of, and it doesn't have to be long, a paragraph that's 3 to 5 sentences, very short paragraph. Draw some conclusions. So you're going to summarize the results in a paragraph, 3 to 5 sentences. For number 2, you're going to draw some conclusions, yet another paragraph, 3 to 5 sentences. Write a paragraph explaining what you could conclude about the results. The goal of the conclusion is to try to explain why the pattern appears and look for the pattern. You're going to see a pattern. I'm not going to tell you what the pattern is. Why the results of the right are so different from 2 to 64K bytes. Why do the results for right and F right differ? And what can you conclude about the way in which the F right works? And buffering, I will tell you, is a little hint there. One of them buffers, the other one doesn't buffer. So the overall effects of buffering the memory and using memory as a buffer is pretty much a good takeaway going on here. And note that performing the experiment and summarizing results are separate steps, and both come before you draw conclusions. So to present honest and understandable results, you must present the data first. So the reader can draw their own conclusions while looking at your data before you insert any of your biases. And yeah, you're probably going to insert some bias, and that's fine as well. So what are you going to hand in? You're going to hand in your source code and your analysis files. So again, you can take number 2 and number 3, and you can put it in the body of the email message that you send me, along with your attached source code. Or you could take number 2 and number 3 and put it in comments in the code. Or you could take number 2 and number 3 and actually print it out to the screen if you wanted to. Put it in the code so it prints out to the screen. I'm not expecting more than 2 paragraphs. I want 1 paragraph about your summary of your results and another paragraph about the conclusions that you can draw from looking at these results. And they're both going to be biased probably, depending upon, well, actually number 2 is probably not going to be biased unless your program is biased in terms of how it creates its results. But yeah, some conclusions are going to be your thoughts. You're going to draw, that's going to be biased. And don't spend too much time writing it. It's not a research paper. I don't need any references, and don't use any references. How are you going to use references here anyway? You're not going to use references. You're not going to do any research for this. What you're writing about is your experiment that you're writing. You're writing about the results of your experiment. Don't take your source code from the internet. Write the source code yourself. Simulate the loops. You can automate this whole thing. It's not that tedious. You're writing a program to run this experiment. And then you're going to compare your results, and then you're going to draw some conclusions. None of this can be found on the internet. None of it should be found on the internet unless you find somebody else who did the assignment and the assignment's out there or something. But yeah, just be honest with it, is what I'm saying. Don't plagiarize. I don't want to hear the history of F right and right. I want you to write about what you saw in the results. So if you have any questions, you can always send me an email message. This is the last assignment for the Operating Systems Design course, and the purpose of this assignment is to give you some insights into the design of system programs and how system programs differ from API level programs, and how memory plays a part with this, and how the efficiency of using the memory and using buffering also plays a part in the design considerations when designing systems programs. So if you have any questions, please feel free to send me an email message. Otherwise, the assignment is the last assignment for the course, and it is due on the last day of class. And it can be found in the assignments folder along with all of the other assignments. So I hope you have enjoyed the video, and stay tuned for another video coming soon. I will eventually be giving you some final exam hints. But for the most part, if you're curious about the final exam, it will be during the final exam week. It is not a face-to-face exam. It will be done through Blackboard. It will be 15 short answer questions that you'll answer in a time-controlled environment on Blackboard. That is, it'll be impossible to Google the answers to it, because the questions themselves are going to be extremely unique and non-Googleable. And the more time you spend doing that, the less time you'll be able to spend answering the questions. So it'll be a pretty good test environment, in my opinion. So if you have any questions, that video will be coming out shortly in the next week or so as we get closer to final exam week. I still haven't finished creating the final exam yet, so once I get done with it, I will populate it in Blackboard. It will open up for a particular time period. You will take it, and then it will close. So I will have more details on that soon. Have a good rest of week, and stay healthy and stay safe at home. Talk to you later.